outsiders subjugating us as they are on their way, Neil deGrasse Tyson shouts out, affirming the most confounding and unfortunate revelation made by the explorer in the previous 10 years, a disclosure that researchers were not the slightest bit ready for. Since the explorer sent back this upsetting information from space, established researchers have been unable to rest, and everybody is strolling under a strained climate. Specialists, researchers, and architects have been mixed from their stations to battle these mysterious objects that explorer just spotted. We don't have any idea where these unusual items are coming from or where they are going, yet what we can be sure of is that we have seen nothing like them before. What are these baffling objects that were recently found by Explorer 1? Join us today as we analyze these responses in Neil deGrasse Tyson's Explorer 1, which has identified 500 obscure objects passing by in space. For right around 50 years, Explorer 1 has been cruising through the roadways of space, investigating the profound domains that ground-based telescopes have been prohibited from seeing, and uncovering revelations that leave our mouths completely open in shock. As a result of genius personalities that flow in abundance at the Johns Hopkins Applied Physics Laboratory, Explorer 1 has been the brilliant courier to the unfamiliar regions of intergalactic space. This engineering masterpiece has woken us up to the marvelous miracles that exist in our universe. In a new development, Neil deGrasse Tyson has confirmed that Explorer has recognized 500 obscure objects floating calmly in space. This news came as a shock to mainstream researchers, shaking them as everybody began poring over the information gathered by Explorer 1. Something odd was brewing not too far off, and it was challenging to solve this foaming riddle that had stunned even the greatest of researchers. Since Neil deGrasse Tyson confirmed this disclosure, various interpretations have been flying in the air, trying to draw a distinctive picture that makes sense of the secret. Had it been another spacecraft that communicated the kind of stupefying information that was recently communicated from space, researchers might have questioned the validity of the data. However, it is Explorer 1 we are discussing here, the space probe that has been cruising through the vast ways of space for nearly 50 years now and has surpassed our expectations. Like a patient who beat cancer, Explorer 1 has surpassed researchers' expected lifespan of 3 years to spend over 45 years in space, revealing history-making discoveries all the while. The most fascinating part about this famous story is that Explorer is writing this success story from an extremely far distance from Earth. The last time researchers checked, they saw that the space probe was 14.5 billion miles from our planet, dashing away in space with no sign that it would reduce its speed anytime in the near future. Scientists say that the space probe has been going at a rate multiple times the distance between the Earth and the Sun each year. This is one fact that researchers have found a bit hard to swallow because normally one would have expected the space probe's speed to have declined significantly given the longevity of its mission in space. On closer inspection, it appears Explorer 1 is bound to be the exception with regard to this story, and it has shown evidence of this again with its most recent discoveries. It was just like any other day for researchers when Explorer 1 delivered exciting news that would stick in their memories for a long time. Explorer 1 had stumbled upon several strange objects passing by in space. This disclosure was unexpected, which explains the initial confusion among astronomers when they looked over data showing that around 500 obscure objects had appeared from nowhere in a brief moment. We went from having no knowledge of these objects to researchers breaking their brainpower looking for answers to this puzzle that nature had landed on their laps. Researchers were in a fix, and the blame could be traced to just one guilty party, Explorer 1. Suddenly, researchers also knew that the solution to unraveling this mystery also lay on the heavy shoulders of the space probe. At first, when news of this disclosure broke out, some researchers wondered how it was possible that it might have been a mistake. They thought that Explorer might initially be finding it and thus might be communicating erroneous information back to us. If we choose to follow this unfolding path, it seems a plausible explanation given that Explorer 1 was launched as far back as 1977. Almost 50 years of active service for humanity, one could expect that the probe's computers would have become fatigued and started to glitch, faltering in their duties and sending back low-quality data to the ground team. As appealing as this scenario sounds, researchers have advised that we shouldn't settle there as it would be a slap to the sacrificial spirit of the explorer. In spite of the harsh and erratic environment of space, Explorer 1 has consistently produced insightful data about our universe. In opposition to the rushed assumptions of doubters, the the space probe has maintained its long life due to its dual redundant computer systems. Like its twin Voyager 2, Explorer 1 came equipped with two sets of command subsystems, Flight Data Systems, FDS, and Attitude and Articulation Control Systems, ACS. This has been the secret force behind the spacecraft's resilient fighting spirit when it comes to navigating through space and uncovering discoveries. The redundancy allowed for continuous switching between systems and the ability to activate dormant computer parts, thus preserving their life expectancy. While designing Explorer 1, the engineers on Earth devised a plan to enhance the spacecraft's efficiency. This required that the probe's instruments rely on simplified systems as they were constrained by time requirements and power budget limitations. Electrical engineers decided that the instruments needed to be developed using simplified systems that depended on hardware logic. Hence, Explorer's computer systems contain 6 onboard computers organized as a distributed system with 3 dual redundant pairs. Having overcome this hurdle, researchers faced the next tall order, maintaining the systems. This daunting level was conquered by devising a continuous power management plan. Here's where it gets a bit tricky. Power management involved sustaining the operational functions of Voyager's computer systems, and to be honest, this is a strenuous task given the limited power resources available on board the spacecraft. It was a case of sending a tracker into the deep wilderness to hunt wild creatures with only a handful of tools. Nevertheless, researchers found a method to get around this issue by devising several measures to monitor and optimize power usage on board the Explorer. A real example of these power management measures that specialists devised is the strategic shutdown of non-essential systems. Engineers were forced to make this tough decision and used a systematic approach to identify and deactivate parts or subsystems that are not critical for the spacecraft's primary mission objectives. We see evidence of this when we look at heaters associated with certain instruments that had to be turned off. These heaters were initially intended to maintain the instruments at specific temperatures for optimal performance. However, the story had to be reworked by activating them only when necessary because it greatly reduced power consumption on board the spacecraft. This reduction in the spacecraft's power use has a ripple effect. It extends the probe's lifespan. This is a win-win situation for everyone. Also, we should remember that the decision to shut down non-essential systems is not taken lightly. Such a planned action requires careful consideration of the trade-offs between power conservation and the scientific objectives of the spacecraft. Whenever such a decision was made, all hands had to be on deck. Specialists and researchers needed to come together and assess the impact of deactivating specific systems on the quality and availability of scientific data. Emotions were not running the show. It was all about the facts at hand. The team was driven by the desire to maximize power efficiency while maintaining the essential functionality of the spacecraft so it could continue to gather valuable data about our universe undisturbed. Engineers and researchers alike wanted nothing to prevent Explorer 1 when it came to uncovering the deep mysteries locked away in the secret domains of space. Mysteries that the universe has been keeping from us for years. However, specific power reduction isn't the only way that NASA specialists are keeping the Explorer afloat and functioning optimally in space. They had another secret weapon up their sleeves, which they needed to bring to the table to help the spacecraft. The specialists needed to devise power management strategies that are adapted to the ever-changing conditions of the spacecraft's environment. For example, as Explorer 1 ventures farther away from the Sun, the available solar energy undergoes a decline. We would agree that this is a problem, but the specialists came prepared. They compensated for this growing threat by ensuring that the spacecraft adjusted its power usage accordingly. This adaptive approach is a triumph for NASA engineers and researchers because it ensures that the available power resources are efficiently allocated to support the probe's critical tasks and data transmission back to Earth. Interestingly, the good news doesn't end here. There have been continuous technical advancements and upgrades in power management, which have allowed engineers to refine and streamline the spacecraft's power systems over the years. A close look at these improvements reveals that they involve more efficient power distribution, enhanced battery charging methods, and advancements in power regulation and control. The implementation of well-thought-out and planned power management strategies has opened an exciting door for engineers. It has made it feasible for them to extend the operational lifespan of Explorer 1 alongside its twin Voyager 2. This is a major success for mainstream researchers and the world overall. The careful allocation and management of power resources have provided Voyager 1 with the vital strength needed to continue exploring the depths of the universe. The discovery reverberated through the hallways of scientific inquiry with seismic power. Neil deGrasse Tyson's urgent decree resonated across the globe, emphasizing 10 years of meticulous investigation by Explorer 1 amid the vast realm of interstellar space. The spacecraft had inadvertently found an anomaly of significant importance. 500 confounding entities, their origins and purposes shrouded in cosmic mystery, navigating silently through the void. This unexpected encounter sparked a frenzy of scientific inquiry. Researchers and scientists worldwide began a coordinated effort to understand these enigmatic objects, attempting to decode their origins and purposes. The unprecedented discovery by Explorer 1 opened a new chapter in space exploration, challenging existing theories and inspiring fresh perspectives on cosmic phenomena. The ongoing analysis of this data promises to push the boundaries of our knowledge, potentially revealing new insights into the nature of the universe and our place within it. As we delve deeper into the mystery, the ultimate goal remains to uncover the truth behind these obscure entities and their impact on our understanding of space. As scientists continue to delve into the mystery of the 500 obscure objects identified by Explorer 1, the scope of research has expanded dramatically. The initial data gathered by the spacecraft has already led to several intriguing hypotheses. One theory suggests that these objects could be remnants of ancient cosmic events, possibly debris from exploded stars or disintegrated asteroids. Alternatively, they might be composed of materials unknown to current science, hinting at novel forms of matter or even entirely new physical phenomena. Astrophysicists are utilizing advanced computer models to simulate the trajectories and potential origins of these objects. By analyzing their paths and velocities, researchers hope to determine whether they share a common source or if they originated from multiple, distinct events. This aspect of the study is crucial for understanding the broader implications of the discovery, such as the possibility of previously unrecognized cosmic processes or interactions. Observatories around the world have been enlisted to assist in tracking these objects. Ground-based telescopes are being used to verify and complement the data returned by Explorer 1, providing a more comprehensive view of their characteristics. High-resolution imaging and spectral analysis are key components of this effort, aiming to detect any chemical signatures or physical properties that could reveal more about their nature. In addition to observational efforts, theoretical physicists are exploring the potential impact of these discoveries on our understanding of fundamental physics. For instance, if the objects exhibit unusual gravitational effects or electromagnetic properties, they could offer insights into theories of dark matter or dark energy. Such findings could revolutionize our grasp of the universe's most elusive components. The discovery has also spurred interdisciplinary collaboration. Cosmologists, mathematicians, and even experts in materials science are contributing their expertise to solve the riddle posed by these mysterious objects. This collaborative approach is fostering a more holistic understanding of the data and ensuring that all possible angles are explored. Educational institutions and research centers are now incorporating this new cosmic mystery into their programs, using it as a teaching tool to inspire the next generation of scientists. Public interest in space exploration has surged, with many people eagerly following the progress of the investigation. This renewed interest in space science has led to increased funding and support for space missions and research, reflecting the broad appeal and importance of the discovery. Moreover, the implications of the discovery extend beyond the realm of science. If these objects are found to possess unique properties or behaviors, they could have practical applications in technology and industry. For example, if the objects contain novel materials with exceptional strength or conductivity, they might be used in advanced manufacturing or electronics. As the investigation progresses, the scientific community remains cautious but optimistic. The data returned by Explorer 1 is being scrutinized rigorously to rule out any anomalies or errors. Peer review and replication studies are integral to validating the findings and ensuring that the conclusions drawn are robust and reliable. In summary, the discovery of 500 obscure objects by Explorer 1 has opened a new frontier in space exploration. The ongoing research into these enigmatic entities is poised to expand our knowledge of the cosmos, challenge existing theories, and potentially reveal groundbreaking discoveries. The collaborative efforts of scientists worldwide underscore the significance of this finding and highlight the enduring quest for knowledge that drives space exploration. As we await further revelations, the excitement and anticipation surrounding this cosmic mystery continue to grow, promising new insights into the universe's deepest secrets.